I'm going to show you what chemical tea is about, and also then the chemical tea with a twist. So chemical tea is essentially a chemical demonstration that will show is the same as the preparation, same chemicals used for the preparation of oxygen gas, which is on the junior cert syllabus, the current junior cert syllabus. So what happens is that we react essentially in the chemical reaction that hydrogen peroxide, which we can see looks exactly like water, becomes decomposed by the catalytic reaction of the chemical manganese dioxide. Okay. Now the chemical tea reference is that we know that to make a proper cup of tea that it needs to have boiling water. So when these two chemicals are added together and reacted, that it does indeed produce steam, boiled water in the form of steam. And if you could had a kettle or an old copper kettle or teapot, you could put the two chemicals into this, and it gives a lovely demonstration of a boiling teapot. Here, if you don't have that, we can, as an alternative, just use a cup. So I'm going to demonstrate that here by adding the two chemicals together, and there you get the steam, the chemical tea steam effect. Okay, now, so what you saw there is we saw indeed a lot of gas, a big puff of gas and smoke, essentially, coming out of the cup. But in order for the preparation of oxygen, how can we prove that indeed that the gas that was released from the reaction between the two chemicals was indeed oxygen? So by adding simply wash up liquid into the solution, into the reaction, the wash up liquid will act to trap the gas, to trap the oxygen gas, and then by rekindling the glowing splint, which is the test for the property of oxygen gas, that it is oxygen gas, we can do that in the following way. So first of all, add some wash-up liquid into a graduated cylinder. Add a small amount of water, so make a very concentrated solution really of wash-up liquid solute, so small amount of water. To that then we will add our liquid first, the hydrogen peroxide next. Sorry, we're actually going to add the manganese dioxide next, which is our catalyst. Now when you're adding the manganese dioxide to the solution of wash-up liquid solution, be careful, try and get it all down into the container, and probably a good idea to try and stir it, and I might just use my long stick here for that. Try and give it a stir in order that you can get as much exposure of the manganese dioxide to the hydrogen peroxide when you add it. Okay, so here we're going to add, and because of the presence of the wash-up liquid solution, it'll form foam, and the foam will essentially trap the oxygen gas that is being produced. Okay. So what we see here is that a lot of foam produced, and that we know that should have trapped the oxygen gas. And we know that water is also produced in the form of steam from this reaction. And how you can also observe that is usually the evidence of steam can be seen, or you can certainly feel the heat coming off the reaction. Now, so this is our test for the presence of oxygen gas, is that if I light a wooden splint, let it burn till you see the orange embers, and at that point blow it out, and then place it into it, and it should relight the splint. And you can do that a number of times, and it's a lovely opportunity for students to engage in the class, by letting them all have their own wooden splint and to carry out that, and we can see here again how it relights the glowing splint, and you can see the flame through the foam itself. So this is chemical tea with a twist, showing how the preparation of oxygen gas, and demonstrating that the property of oxygen is that it rekindles a glowing splint.